car. Let's find it out in this video in which we explain the steering system's functions. What's fascinating in cars is that when we turn the front wheels, all the vehicle will turn in that direction. But why does a car follow a precise curve after steering instead of proceeding in a straight line? To find the answer to this question, we need to know the physics of the wheel, one of the greatest inventions in human history. The speed of an impeccably rolling wheel at the contact point should always be 0. This will guarantee that there won't be any slippage between the stationary road and the wheel at the contact point. The moving wheel can have 0 velocity at a point in its surface because it has two sorts of movement. It moves indeed in the trajectory of the car, and it also rotates along its axis. When we sum these two factors at the bottom of the wheel, we can point out that they are in opposite directions and they reset each other's results. This elementary rule is essential to comprehend the steering mechanism. Considering also that, even after the wheel turns, the car keeps on moving straight away. Therefore, if we checked the translational and rotational velocities at the contact point of the wheel, we would notice that the rotational velocity situation is inclined, but on the other hand, the translational velocity is straight. Thanks to this fact, the velocities do not reset each other's value, and this will make the car skid. The only way to succeed in achieving the 0 velocity condition is to grant that the translational velocity is inclined as well. This phenomenon takes place when the entire car turns with respect to a center point. This is conceivable only in case the whole vehicle turns with respect to a center point. In this view, this fact is accurately represented. All the wheels encounter the perfect settings of rolling. In addition, another fundamental aspect to be addressed is that for this impeccable kind of turn, the perpendicular lines from the front wheels should meet the rear wheel axis at a mutual point. This condition is the principle of steering. If you analyze, you will realize that the angles curved by the left and right wheels are not equivalent. More than 10 years in industrial supplies have led Jay's to become a qualified partner for some of the most important automobile manufacturing companies, providing its technical support over a wide range of industrial components necessary during the production process of many types of vehicles. What are the mechanism and outcomes? In order to get the perfect steering, the left and right wheels should turn at different angles. The steering mechanism is used to accomplish this scope. The most ordinarily used steering mechanism in contemporary vehicles is the rack and pinion kind. Let's have a look at how this mechanism copes to steer the vehicle. A rack, which is the midpoint of this mechanism, is constrained in order to only move along a straight line. The steering pinion can urge this rack the movement of a part denominated a steering arm, which is attached to both wheels. This section is limited in its movement and, in this way, it only has a rotational motion along the axis. The steering arm is linked with the car frame thanks to a roller bearing. This ensures that it can only turn. A tie rod is the linkage between the steering arm and the rack, and it can have both translational and rotational motion. Let's check what occurs to the wheels when the rack moves. You can observe that the left and right wheels are turning at different angles. If you monitor the meeting point of the left and right wheels, you can realize that the meeting point always lies on the rear wheel line. Hence, the rack and pinion mechanism totally satisfies the conditions needed for steering, and on account of this, the vehicle makes it turn without slipping. The steering, which can be analyzed up to now, was the manual type. Today, electric motor-assisted power steering is widespread on the majority of cars. Electric power steering pledges the steering action with no effort and more accurately. Stepping forward, we can see a brushless DC motor, which drives the steering column and pinion and shows its capability of rotating in both clockwise and counterclockwise directions. An electric control unit settles the amount of power that the motor should transfer to the column. Then, the ECU receives certain inputs, such as the torque the driver has applied to the steering wheel, the steering angle, the steering wheel speed, and the vehicle speed, and then it decides the appropriate torque to be supplied. A Hall effect-based sensor and torsion bar arrangement is commonly used to quantify the driver's torque input. Owing to the motor's power assistant, the steering wheel rotation gets effortless for the driver. Even in case of a tire puncture, the power steering system goes into action by helping the driver to control the vehicle's trajectory. In addition, if the steering wheel is too hard to turn, probably there are some issues with the steering gear, or it might mean that the power steering's broke.